Hi class. Today we're going to be talking about section 7-4, which is on factoring polynomials. This is our first notes into factoring. We've already talked about adding, subtracting, and multiplying polynomials, and now for the remainder of the unit we'll talk about factoring polynomials. So before we talk about factoring polynomials, I first just want to talk about what a factor is. Do you remember making these factor trees? I have two examples below, one for 36 and one for 28. These are called factors because they're the numbers that we multiply together to get that product. So these factor trees tell us when we split up 36, we get factors 2, 2, 3, and 3. And that tells us that if we multiply all those numbers together, all of these factors together, 2 times 2 times 3 times 3, we'll get the product 36. Or for 28, we get factors 2, 2, and 7. So that tells us that if we multiply together the factors 2, 2, and 7, we get the product of 28. Let's go ahead and list all of the positive factors of 24. So these are numbers that multiply together to get to 24. Well, I know that 1 times 24 is a pair of factors. Go ahead and leave yourself some space. I know 2 times 12 gives us 24. I can multiply 3 times 8. And I can multiply 4 times 6. These are all of the factors of 24. Now the factors of 30, I can multiply 1 and 30. That's a pair of factors. I can multiply 2 and 15. I can multiply 3 and 10. I cannot multiply 4, but I can multiply 5 times 6. So these are all the factors of 30. Now I want to determine the greatest common factor. So first, let's determine what are some common factors of 24 and 30. Some common factors include 1, 2, 3, and 6. Now I want to know what's the greatest common factor. So of these common factors, which is the greatest? The answer is 6. Next, I want to find the greatest common factor of 18 and 33. So start thinking about what numbers you can multiply together to get to 18 and numbers you can multiply to get to 33. Well, in my mind, I'm thinking for 18, I can do 1 and 18, 2 and 9, and 3 and 6. For 33, in my mind, I'm thinking 1 and 33, 3 and 11, and that's it. So the greatest common factor in this case is 3. So now let's actually talk about factoring. I've mentioned that factors are pieces to a multiplication puzzle, right? Or a multiplication problem. It's what you multiply together to get a product. So factoring is the process of reversing the distributive property. We know that the distributive property is a means by which we multiply, so then factoring is going in reverse. It's finding what pieces we use to multiply together to get the product given by the distributive property. Okay, this is called factoring because factors are part of an expression that are multiplied, so factoring turns a simplified expression into a product. So what does that mean? Let's first consider the distributive property. If I were to say simplify the expression 5 times the quantity 2x plus 9, you would distribute that 5 into each of the terms. So you would multiply 5 times 2x, and then you would add it to 5 times 9. And we would get the product 10x plus 45. Likewise, if I were to multiply these two binomials, x plus 5 and 2x plus 9, we would use FOIL, first, outer, inner, last. So our first and outer, we would have x times 2x and x times 9. So we have this here, x times a quantity, 2x plus 9. And then our inner and last, 5 times a quantity, 2x plus 9. And then distributing, we get 2x squared plus 9x plus 10x plus 45. And combining like terms, we get 2x squared plus 19x plus 45. So in order to factor, we're essentially taking the product here. We're going to take the product, and that's going to be our starting place, but then we're going to move in reverse and get those factors. So if we started with 10x plus 45, the goal is to get back to 5 times the quantity 2x plus 9. Or likewise, to go from 2x squared plus 19x plus 45 back to the product of the two binomials, x plus 5 and 2x plus 9. Okay? So in order to do this, we first have to consider the greatest common factor. So consider 10x plus 45 again. The greatest common factor between 10x and 45 is 5, right? We can pull out a 5 from each of those quantities. Once we do that, if we just divide out a 5 from 10x, we're left with 2x. Divide out a 5 from 45, and we're left with 9. We have 5 times both of these quantities, so we can just take 5 times that entire quantity. Okay? We're going to learn how to factor this trinomial up here once we reach 7-5. So let's go ahead and factor out the greatest common factor. Go ahead and flip the page. This first example, I want to find the GCF of 2x squared plus 6x minus 10. Now, sometimes it's helpful to write out each of the factors for each of these terms. So for 2x squared, that's the product of 2 times x times x. For 6x, it's the product of 2, 3, and x. And for negative 10, we have negative 1 times 2 times 5. So in order to find the GCF, we can find all of the common factors of its prime factorization and then take the product. So I see that in each of these, there is a 2. And that's it. Only some of these have x's, some of these have 3's. One of them has a negative 1 and a 5, but none of them have another thing all in common. Therefore, our common factor, our only common factor, which is also our greatest common factor, is 2. Letter B, let's go ahead and factor out the GCF for x to the 7th plus x squared plus x to the 4th. Now I'm looking at these. I see 7 x's in the first expression, the first expansion. I see 2 x's in the second, and I see 4 x's in the third. And I want to find what's common in all three of these. Well, the only thing that is common in all three of them are 2 x's. So we can pull out 2 x's from each of these. We can't pull out any more because as soon as we hit 2, we can't get anything more from x squared. Therefore, our GCF is x squared. In general, when you're looking at variables, you're going to be able to pull out the variable with the lowest exponent. So in this case, x squared. You can pull out 2 x's. So then let's find it for this here, but let's do it without writing out all the factors. Let's start with the numbers in front, the coefficients. I'm looking for the GCF for 8, 4, and 20. Well, I notice that 2 goes into all three of these numbers, but I also notice that 4 goes into all three of these numbers. Now, that would be our greatest common factor. For our variables, I see each of them have variables, so we can pull at least one out. Now consider the lowest exponent. We have 6, 5, and 4. Out of all of these, we can take out 4 x's. So we have 4x to the 4th. Okay? When we pull out 4 x's, there's none left over in the third term, 1 left over in the middle term, and 2 left over in the first. Let's get some actual practice here. All right? So the first one, we have 9m plus 15. Let's just first consider the numbers. In both of these, the GCF of 9 and 15 is 3. And then I can't pull out any variables because only one of these has a variable. It's not a common factor. Letter B, I've got a sum of 3 variables here. So all of these have w. I'm going to take the lowest power here is 1, and that's all we can pull out. So just w. For letter C, I'm considering the numbers here, 2, 4, and 5. Each of these, the greatest common factor is 1. So we could write 1, or we don't have to. Now we look at the variables. We have b to the 3rd, b to the 5th, and b squared. We're going to take the least of those, so b squared. And last but not least, 4, 10, and 8. We could pull out a 2 from each of these. And then I see y, z, y, and z. So we cannot pull out any of the variables because there's not a common factor amongst all 3 of those. All right. Last but not least, let's go ahead and factor out these expressions. So consider 8x minus 22. So the common factor here, the greatest common factor is 2. And what's left over, if we divide out 2 from 8x, we're left with 4x. Divide out 2 from negative 22, and you're left with negative 11. Now we can go back and check by redistributing it. Remember, factoring is like reverse distribution. So if we go ahead and distribute, we can go back and see if we get what we started with. 2 times 4x is 8x. 2 times negative 11 is negative 22. And indeed, that's what we started with. So we're good. Next up, our coefficients. I see 2, 3, and 4. The greatest common factor of those is 1. Now I look at the x's. We've got 1x here, 2x here, and 1x here. So we can pull out 1x from all of those. And then look at our y's. We've got 1 here, none here, and 2 here. So because this middle term doesn't have any y's, we can't pull it out from every single term. So we can only pull out x. When we pull out x for the first term, all that's left over is 2 and y. When we pull out x from 3x squared, we have 3x, just 1x. Remember, we're dividing out an x, so we're going to subtract that exponent, 2 minus 1. And last but not least, dividing out an x from 4xy squared, we're just left with 4y squared. And we can check this by plugging it back in and redistributing. So x times a quantity, 2y plus 3x plus 4y squared. And redistributing, we get x times 2y is 2xy. X times 3x is 3x squared. And x times 4y squared is 4xy squared. And indeed, that's what we started with. So we're good. All right, there's 2 more. Try these on your own. Go ahead and pause the video and unpause to check your work. All right, so for number 1, I'm looking at coefficients. The number in front of this w cubed is 1. Our greatest common factor for the coefficients, 1, 2, and 6, is 1. And then I see we've got w's in each of these terms, so I can pull out the least exponent here, which is 1. So I'm going to pull out 1w. What's left inside is w squared plus 2w plus 6. And that's our answer. For the next one, I'm looking at coefficients 6, 9, and negative 21. I can factor out a 3 from all of those. Now let's look at our x's. I don't see any x's in the first one or the second term, but I do see it in the third. Since it's not in all 3, we can't pull out any x's. Our y's, I see a y cubed, and y cubed. So they all have a y cubed in common. I can pull that out. And last but not least, we have a z cubed, z, and z squared. So I can pull out a single z. And what's left over on the inside, if I pull out a 3 from 6, that gives me 2. Pull out a y cubed from y cubed, and that takes out everything. Pull out a z from z cubed, and we're left with z squared. Plus, pull out a 3 from 9, you're left with 3. Pull out a y cubed from y cubed, there's nothing left over. And pull out a z from z, and there's nothing left over. So it's just 3. Minus, divide out 3 from 21, and you get 7. There is no x that we're pulling out, so that stays there. Y cubed divided by y cubed cancels out, and z squared divided by z is z. And that's our answer. All right, so we're going to get a whole lot of practice on factoring the GCF. So study up, and we'll see you tomorrow in class. Have a great day, everybody.